Hello students, today we will see how to get transfer function from block diagram reduction. Okay, see we have not seen yet to get transfer function from block diagram reduction technique. Okay, but we have seen how to get transfer function from signal flow graph. Okay, so we will see how to get transfer function from block diagram using signal flow graph. Okay, so look at this is block diagram. Okay, so when the question is asked to find transfer function from block diagram, okay, here method is not mentioned. The question can be asked to get transfer function from block diagram reduction technique. If the question is asked to get transfer function from block diagram reduction technique, so you need to use all the block diagram reduction rules. Okay, but here the question is asked to get transfer function from block diagram. Okay, so we have seen signal flow graph. We can find transfer function using Mason's gain formula, and that is easiest method to get transfer function. This is easiest, as well as I will say this will save your time. Okay, because block diagram reduction technique is little bit time consuming. Okay, so if it is not given, the method is not given, we will use Mason's gain formula, that is signal flow graph. Okay, so there are some rules while converting block diagram to signal flow graph. Okay, so we will discuss about the block diagram because we have not started with the block diagram reduction yet. See, this is called as summing point. Okay, this point is called as takeoff point. Okay, you can see this is takeoff point, summing point, takeoff point, takeoff point. Generally we are using this term as a node where the branches are incoming or outgoing signals will be there. So this point is called as a takeoff point. Okay, so for conversion of block diagram to signal flow graph, we are following some rules. Okay, these are not hard and fast rules, but we will follow some rules. See, rule number 1. We will consider the number of nodes according to input node, that is input, summing point, takeoff point and output. So this will be fixed. Input node, output node, it will be fixed. And in between input and output, we have to consider the nodes for summing point as well as takeoff point. Okay, so we will start so that you will get the actual idea for conversion. Okay, see here input signal is there and then takeoff point. So I will consider node number 1 as a takeoff point. Okay, then summing point is there, so I will consider this as node number 2. So generally what we are doing, if takeoff point is before summing point, in that case we are considering these two nodes as a separate node. So there is no gain in between these two nodes. If there is a gain, so no doubt we have to consider it separately. Okay, now see here, node number 1, node number 2, then again summing point, so I will consider these as node number 3, then gain, then this is takeoff point. Okay, so node number 4. So you can see here takeoff point is there and summing point is there. So in between node number 3 and 4, gain G2 is there. So we need to consider these two nodes as a separate node. Okay, we cannot consider these two as a single node. Then next, again see here, this is node number 4, then takeoff point. I will consider this point as node number 5. Okay, and just now I told you, if takeoff point is before summing point, then we will consider these two nodes as a separate node. So this is node number 6. Okay, see in between 5 and 6, no gain is there. So what we will do, we will consider a unity gain in between 5 and 6. Okay, so I hope you got the concept for considering the number of nodes. Then we will convert this block diagram to SFG. Okay, so I will draw this node 1, node number 2, node number 3, node number 4, 5 and 6. Okay, So these are 6 nodes. Now we will join all these nodes according to the block diagram. See here R is an input signal, that is input and incoming to node number 1. Now see, in between 1 and 2 there is no gain, so I will consider this as a unity gain. Okay. Next, from node number 2 to 3 you can check there is a block G1. Okay, so I will write G1 here. Then from node number 3 to 4 you can check 3 to 4, so G2 is there. See here direction is not given, but this is actually the forward direction. Okay, from 4 to 5 this is again forward direction. G3 is there, so I will consider G3 here. Then from 5 to 6, okay, 5 to 6 no gain is there, so we will show this with a unity gain. And what about this 6? After 6 that is nothing but output path or output signal. Okay, so you can show this C, the node name as C also. Okay, see here. Next, then from node number 4 to 2, look at this, node number 4 to 2 there is no feedback gain here, so we will consider this as a unity gain. Okay, but see the signal that is negative, so from 4 to 2, okay, so I will show this with -1. Okay, 4 to 2 -1. Then from 5 to 3 again feedback is there, but that is positive feedback. 5 to 3, okay, so 5 to 3, see the direction, so I am saying feedback with unity gain 5 to 3. Okay, now next you can see here the signal is going from 1 to 6. Okay, so see the direction 1 to 6. Okay, and what is gain here? G4. Okay, so this is signal flow graph from the block diagram. Now we know how to get transfer function from signal flow graph, so we will solve that. But before that I will write a Mason's gain formula, transfer function by Mason's gain formula. So that is C of S, Laplace transform of output to Laplace transform of input, is given by summation of Pi delta I upon delta. Okay, so this is Mason's gain formula. Now see, as we know that we will solve this SFG, okay, with step number 1. So what is step number 1? Step number 1, we need to find the summation of Pi. Okay, so Pi is nothing but the forward path gain. So I will check here step number 1 as number of forward paths. Okay, so look at this, how many forward paths are there? I can see here there are 2 signals that are starting from input and it will end at output. So 2 forward paths are there. So I will write a forward path gain. See here R is the input. Okay, so 1 into G1 into G2 into G3. So first forward path is G1, G2, G3. Okay, next second forward path P2 is equal to, look at this, here R is there, no need to consider. Then from 1 to directly C, so G4 path is there. Okay, so this is forward path 2. Then step number 2. Step number 2, we know that we need to find individual loops. Okay, we need to find individual loops. Now look at this and try to get number of individual loops. We know what is loop. Loop is nothing but a closed loop path. So you need to calculate a closed loop paths here. So look at this. Okay, so first loop I am getting like this, G1 G2 into -1. Okay, so I will write here L1 is equal to here minus, so G1 G2. Okay, now see here one more loop is there, that is G2 G3 into +1. So I will write here G2 G3 into +1, so plus. Now look at this, I can consider whether I can consider this loop. No, because you can see the direction of G4 here. G4 is a forward path or the parallel path. Okay, so this is not a loop. For loop there should be the complete closed loop path. See the direction for the loop. Okay, starting from node number 2 and ending at node number 2. Here also it is starting from node number 3 and it is ending at node number 3. So you can consider here only 2 loops are there. Okay, so now step number 3, you need to find 2 non-touching loops. Okay, So you can directly check from signal flow graph, there are no pair of loops which are not touching each other. Okay, so we will not write here step number 3 for two non-touching loops, as two non-touching loops are not there, so there is no doubt three non-touching loops will not be there. Okay, so next we have calculated that P1, then we need to calculate that delta I. Okay, so I will write here delta I, this term depends on the number of forward paths. So in this SFG, how many forward paths are there? Two forward paths. So there will be two terms, delta 1 and delta 2. Okay, and we know the formula for delta 1. What is formula? 1 minus in bracket. 1 minus in bracket, we have to check whether there is any loop which is not touching to first forward path. Okay, we have to check whether there is any loop which is not touching to first forward path. So what is your first forward path? G1, G2, G3. So look at this, G1, G2, G3. So these two loops are touching to first forward path. Okay, so what I will do, I will write 0 because all loops are touching, so delta 1 is equal to 1. Okay, now delta 2. See, delta 2 is equal to, you have to check the second forward path. Okay, so second forward path is G4. Okay, so I will write the formula 1 minus in bracket. I have to take sum of loops which are not touching to this second forward path. I have to take sum of loops which are not touching to this second forward path. So you can check this loop is not touching to this path and this loop is also not touching. So L1, L2 both are not touching to second forward path. Okay, so I will consider here sum of loops. So loop number 1 is minus G1, G2. Okay, sum of loops. So plus second loop, that is G2, G3. Okay, so these two loops are not touching to this second forward path. Okay, so we have completed with all the terms. Now we will calculate the transfer function. Okay, so transfer function is Laplace transform of output to Laplace transform of input. Okay, so I will write here summation of Pi delta I means P1 delta 1 plus P2 delta 2 upon delta. Okay, so we know that what is delta? Delta is equal to 1 minus in first bracket sum of all individual loops plus in second bracket sum of two non-touching loops minus in third bracket sum of three non-touching loops. Okay, so accordingly I will write here P1 is equal to G1, G2, G3. Okay, delta 1 is equal to 1, so multiplied it with 1. Then P2 is equal to G4. Okay, and here I will write 1 in G4 multiply by delta 2. So multiply by 1, I will do like this, 1 minus in bracket minus G1, G2 plus G2, G3. You can rearrange. Okay, so this is the formula, or I will write like this, so there will not be any confusion. Okay, so upon delta. So what is delta? Delta is equal to 1 minus sum of individual loops. So how many loops are there? Two loops. So I will write sum of individual loop as minus G1, G2 plus G2, G3. Okay, here minus is there, so in second bracket it will be plus, but as you know that two non-touching loops are not there, then minus three non-touching loops are not there. Okay, so you will put 0 here. So are you getting? See here, we have calculated the transfer function. Okay, by substituting simply the value. You can rearrange this, you can take out the negative sign. Okay, common. So this is the simple method to get transfer function. Okay, so if the question is asked to get transfer function and method is not mentioned, so it is really very easy to convert block diagram to SFG, then apply Mason's gain formula and calculate the transfer function. Okay, so I hope you got the concept of converting block diagram to signal flow graph. Okay, so thank you students.